Secondary bonding. In earlier lectures, we studied ionic bonds, covalent bonds, and metallic bonds. These bonds are called primary bonds because in this bond there is a sharing of electrons or the transfer of electrons takes place. But in this lecture, we are studying secondary bonding. In the secondary bonding, there is no transfer of electrons or no sharing of electrons. In this secondary bonding, this is bonding without sharing or transfer of electrons, and hence it is called secondary bonding. There are two types of secondary bonding, van der Waals bonding as well as hydrogen bonding. Let us see first van der Waals bonding. In this van der Waals bonding, the attraction between atoms is because of a symmetrical distribution of positive and negative charges. Positive and negative charges in atoms. Let's see what is this asymmetrical or symmetrical distribution of positive and negative charges. This van der Waals bonding generally found in noble gases. As we know that these noble gases characterized by they have filled electron shells. All shells are completely filled, they form a closed structure. So noble gases are more stable atoms. And in this, there is a symmetrical distribution of electrons in free atoms. Symmetrical distribution of electrons in free atom, in a separate atom. And one more characteristic is in crystal of noble gases can form a crystal structure or it can be solid at low temperature. So in a crystal of this noble gas, this atoms packs in FCC structure. So what is this symmetrical distribution of electrons in free atom? Let's say this is the atom. At the center there is a nucleus, and surrounding this nucleus there is electrons which are distributed equally in all sides. So this distribution of charges is called the symmetrical distribution of electrons around the nucleus. In this case, we can see that there is a symmetrical distribution of electrons around nucleus. So this is observed when atom is separated. But if you bring these atoms together, so when two atoms brought together, what will happen then to this symmetrical distribution of electrons? Let's see that. Here is one atom, and let's bring second atom close to the first one. Both these atoms are having nucleus at the center. Then what will happen to the symmetrical distribution of electrons? These electrons are negatively charged electrons. So these negatively charged electrons are slightly attracted or drawn towards nucleus of the other atom. There will be the attraction between the nucleus of one atom and electrons of the other atom. And because of this attraction, a slight charge distribution occurs simultaneously. Charge distribution occurs simultaneously in both atoms. Like, say, when the electrons of the first atom are attracted towards nucleus of the other atoms. So there would be more electrons towards the right side compared to left side of this atom. So these electrons are attracted towards the positive nucleus of the other atom. Now electrons are shifted towards the right hand side. That causes the repulsion of electrons in the second atom. So the electrons in the second atoms also shifted slightly towards the right side because repulsion between the electron cloud. And so in this atom what happens? Slight charge, that is delta positive, is developed on left hand side of this atom and delta negative is developed on the right side of the atom. Similarly for the second atom also, here is a delta positive and here is a delta negative. So there is a asymmetrical distribution of the charges. In this case, you can say that there is asymmetrical distribution of electrons in both atoms. And this asymmetrical distribution of electrons in the both atoms creates small temporary dipoles. In both atoms. And these dipole movements of both atoms attracts towards each other or interact with each other. Like these are the dipole moments. In this, there is a positive charge here, negative charge, positive, negative, positive, negative, and there would be interactions between like this. There would be the interaction between the dipoles. So there is a coupling between two dipoles takes place. Coupling between two dipoles. One caused by fluctuation of charges and other induced by electric field produced by the first one. So in the first atom, there is a fluctuation, and so the dipoles are produced. And because of this fluctuation, the electric field is produced. One side there is a slight positive charge developed, in another side there is a slightly negative charge developed. So this electric field of the first atoms produce the dipoles in the second. And this results in attractive forces between atoms. And this attractive force between the atoms called van der Waals force. Let's see the properties of these molecular crystals. The first, melting and boiling point. Of course, very low. Reason being, van der Waals forces are weak, very weak. Hence, they have low melting and boiling point. Second property about the electrical conductivity, very poor as there are no free electrons. About its hardness is very low because these materials have no mechanical strength and they can easily be formed or compressed. So this is van der Waals bonding. Next type of secondary bonding is hydrogen bonding. Next is hydrogen bonding. Now you know that this hydrogen atom has only one electron. So these hydrogen atoms can form covalent bond with only one other atom, with only one atom. because it has only one electron, so it can form covalent bond with only another single atom. But this can also involve in an additional electrostatic bonds with the second. So it can form one covalent bond, but it can have additional electrostatic bond if second atom is highly electronegative, with whom it forming a covalent bond, such as fluorine, chlorine, or oxygen. And in such molecule, what happens, in such molecule, the molecule of hydrogen with fluorine, or hydrogen with oxygen. Such a molecule, in such a molecule, this positive and negative ions, negative ion centers do not coincide. So they produce the dipole, and then there would be interaction between the dipole, that is additional electrostatic bonds will be formed in addition to covalent bond. For example, let's say if hydrogen atom covalently bonded with high electronegative atom, then what happens? The shared electrons pair are attracted towards more electronegative atom. Shared electron pair drawn more towards higher electronegative atom. Let's take the example of water. In water, there is one oxygen atom and there are two hydrogen atoms. So in this is oxygen, this is hydrogen, and this is hydrogen. This oxygen has, two electrons. It has only six electrons. To form, the octet, it needs two more electrons. So it shares its two electrons with two hydrogen atoms, and they form two covalent bonds. This oxygen atom forms two covalent bonds with hydrogen atoms. But electronegativity of the oxygen is more compared to the hydrogen, and so these electrons pair, this one and this one, these two electrons pair are attracted more towards the oxygen atom, and because of that this oxygen atom develops slightly negative charge and this hydrogen atoms develop slight positive charge. So what happens is permanent dipole is formed. Because of this, permanent dipole is formed. And then dipoles attract towards each other by electrostatic force of attraction. There is the electrostatic force of attraction between the dipoles, and that is the additional electrostatic bond is formed. Let me show that over here. This is oxygen and it has two hydrogens. Oxygen, hydrogen, hydrogen. And here is another atom's oxygen, another molecule's oxygen atom. This is hydrogen and this is another hydrogen. This is oxygen. Now this oxygen atom has delta negative charge. This is delta positive, this is delta negative and delta positive. So between these two molecules, there would be electrostatic force of attraction between the hydrogen and oxygen of the another atom. So this is the electrostatic bond which is additional to the covalent bond. And in this case, why it is called hydrogen bonding? Because hydrogen atom is involved in this bonding and hence it is called hydrogen bonding. And why hydrogen bonding are important? Is important in life process. As you know that generally these proteins or nucleic acids, there this hydrogen bonding plays important role. So this hydrogen bonding is important in the life cycle.